Okay, so let's do the tutorial about linearly independence. So okay, as logical points or section from the previous part, you have number 10 example. Let's do only one example. We will do only one example in this tutorial. Okay, so the question says the following. Let's split it into two. Okay, say determine if the following set is linearly dependent or independent in its natural space. So the set S is 1 minus 1 is the collection of the following vectors: 1 minus 1 is 0, 3, 1, 2, and 2, 0, 1. So how do you prove it? How do you prove whether S is linearly dependent or S is linearly independent? What we have to do is we take the linear combination. So we have C1 minus 1, 0 of the vectors in the set, plus C2, 3, 1, 2, plus C3, 2, 0, 1. Okay, and we let it equals to 0. We take the linear combination and we perform Gauss's method so that we can get the values of C1, C2, C3. If C1 is equal to C2 is equal to C3 and it's equal to 0, then we say that the set S is linearly independent. Otherwise, it's linearly dependent. Okay? So this is what the linearly independence lemma we have seen in the previous chapter or in the previous video tells us. So we have minus C1 plus 3C2 plus 2C3 equals 0. And C1 plus C2 equals 0. And we have here 2C2 plus C3 equals to 0. You know, how do we add the vector spaces? The vectors together, we add them component-wise, okay? And here it says it's a natural space. What is the natural space of S? Is the R3, the three tall vectors. Okay, the space made of the three tall vectors. I mean, three component vectors, column vectors. So that is its natural space. So now let's perform Gauss's method. I'm sure you remember how we do Gauss's method. So we use C1 to eliminate the C1s in the row below the first row. So we are going to use C1 to eliminate C1 in row 2 and row 3. So what I'm going to do here is C1 plus C2 is going to be minus C1 plus 3C2 plus 2C3 equals to 0. Let me remove this so that I can have everything on the same line. And here is 0 is add them together, so it's 4C2 plus 2C3 equals to 0. And we have a 2C2 plus C3 equals to 0. Now we have minus half row 2 plus row 3 will give us minus C. I'm sure you know how to do Gauss's method, okay? And if you don't recall, maybe have a look at my chapter 1. Okay. C1 plus 3C2 plus 2C3 equals to 0. 4C2 plus 2C3 equals to 0. So this is going to be 0 a half minus a half plus minus a half of 2C3 is minus C3 plus C3 is 0. So we have 0 equals to 0. We have already seen how to do Gauss's method, so I won't spend a lot of time to explain Gauss's method. We have done it plenty of times, okay, in chapter 1. So now what I'm going to do is back substitution. So let's do back substitution. Substitution. Okay, and so here what I have done is Gauss's method. Gauss method. Or Gaussian operations. Okay, it's the same thing. Okay, so now this is my row 1, this is my row 2. Now let's write row 2. Let's parameterize those solution set in row 2. So you have 4C2 plus 2C3 equals to 0. That means C2 is equal to minus a half C3. Okay. Now let's sub that into row 1. Row 1 we have minus C1 plus 3C2 plus 2C3 equals to 0. So C1 is equal to 3C2 plus 2C3 equals to 3C2 is minus a half C3 plus 2C3. This leads to what? We have a C1 equals to minus 3 over 2 C3, sorry, plus 2C3, okay, which is equal to a half C3. I'm sure I got everything right. Oh, what have I done? Okay, that's fine. Okay, I think everything is okay. So we have 4, okay, a half C3. So C1 equals to a half C3. I hope I got everything right. Okay. Okay. So this is C1. So basically our scalars C1, C2, C3, a half C3, and C2 is minus a half C3, and C3 is C3. So as you can see, we don't have C1 equals to C2 is equal to C3 equals to 0. The coefficients are not the trivial ones. Therefore, so C1 is different from C2, which is different from C3, which is different from 0. Therefore, S is linearly dependent. That means we can write some vectors as a linear combinations of the others. Okay. Yeah, okay, just a small typo here. Okay, our set here is minus 1, 1, 0. Okay, let's make sure that everything is right. Minus 1, 1, 0. Yeah, I repeat everything. Okay. Yeah. Okay. Yeah. So I think that's fine. We have done it. So we are going to stop here. This is the end of this tutorial. See you in the next video. We'll continue with the lecture. Okay. Thanks.